Welcome to the Balance eSeminar on Data Acquisition Toolkit by Daniel Dubiel. In this eSeminar, our presenter Daniel Dubiel, the Senior Software Engineer, will discuss the NeuroCom Data Acquisition Toolkit software option that's available as an add-on. He will review features of the data software and showcase a demonstration. Learning objectives today. By the end of this presentation, all the viewers should be able to describe the capabilities of the Data Acquisition Toolkit, customize dynamic conditions for specific research studies, understand integration options with other devices, and understand data export options. So what is it? This software is designed specifically for engineers and clinicians wanting greater flexibility and control in designing test protocols and gathering patient data. Data allows the operator to manipulate specific data collection and test parameters and provides easy data export for offline access analysis. The key features: offers turnkey data collection software solution to meet the needs of researchers. It offers 2 modes of operation, sway and ramp, each with customizable settings. It integrates with other devices by providing sync output signal at onset of data collection, intuitive user interface, and abundant choices for data export. It offers population management for multiple research studies. The system requirements for data is that it's compatible with all static and dynamic systems running version 9 or higher. Please note that it's not available for standalone Envision systems. Today we're going to be reviewing a case study on the effects of commercial space travel on balance control systems. We're going to be looking at customizing dynamic conditions, sway and ramp mode, using the head tracker for research, and randomized conditions. Without any further ado, I will be passing the presentation on to Daniel. Welcome, Daniel.
Thank you, Christine. All right. When you install your data software, you will be presented with a new window of buttons on the right. You'll have your research module button settings, which allows customization of things specific to the research module. Data export, which functions kind of like the data analysis, but simply exports your research data into ASCII format files, and then instructions for use, which is the document that you can use if you have any other questions which are not covered here. So let's just go ahead and go right into the research module. Now the file cabinet is just like the clinical module, so I won't spend much time here. I created my subject, Christina Malloy, and I will launch her record, and I will advance right to the main menu. During this presentation, I will cover both the dynamic and stable systems, and just so you know that when you come, the main menu provides you a quick access to either one. So let's just go ahead and select dynamic conditions and click on the setup button. So upon entering to this software, the software defaults to a test called the default test. The default test provides a single condition setting, which tends to be used for quick experimentation in dynamic conditions. Additional conditions cannot be added to this test, and the test cannot be deleted. The software, the user interface has been designed from top to bottom, so that is the flow in which I will cover all of the functionality. Here's where, upon pressing of a new test, we can name the study, and we will cover that in a case study later. Deleting of test self-explanatory. The field name condition. This is definitely something that I recommend in doing. It gives you clarity to to what the settings are doing, as well as in a test on a test screen. It will guide you. It will guide you based on what the sequence of conditions you have created, and especially if you use randomized conditions, it allows you to organize conditions and know what's coming and prepare the patient accordingly. The trial duration. The data software is limited to 190-second trial durations. A faster data rate is selected, like 100 Hz, 500, or 1K, or additional accessory channels are selected. The trial duration is decreased to accommodate this additional data. This limitation is not present on a CRS system, which allows 10 minutes of trials for each trial, regardless of number of accessory channels selected. The software allows of collection up to 8 accessory channels, as well as up to 20 trials per condition. If the system is optioned with the headshake SOT protocol or Envision protocols, the head tracker device will be available for research. This device provides additional 3 degrees of data to your study. The data software on the dynamic system offers 3 motor modes: the sway, ramp, and fixed. The first mode is the sway mode, which permits the rotate and visual motors to sway simultaneously and at different gains. Using this motor mode and available settings, I can recreate the SOT and headshake SOT protocols. In contrast, the CRS system permits all 3 motors rotate, visual, and translate to sway simultaneously and at different gains. The second motor mode is ramp. Data software only allows a single motor to ramp at any one time. By specifying ramp start and end amplitudes along with ramp time and delay, I can design perturbations that represent MCT and ADT protocols. In contrast, the CRS system permits all 3 motors to ramp all or multi-ramp simultaneously. In fact, it also allows mixing of modes where the rotate can be in a waveform mode, which is exclusive to the CRS system, translate in ramp mode, all while the visual is mirroring patient sway. Lastly, the motor position data is only available when a data rate is set to 1 kHz. In contrast, there's no such limitation on the CRS system where the motor position is available in all modes. Finally, the fixed mode does not require further explanation. So the data software allows creation of targets for use in sway modes and in fixed modes. The targets can be sized and positioned anywhere, and they can be configured to express pacing and beep conditions. So for example, I have created 3 targets. If I right-click on the target, I am presented with pacing options, which are unlike the sequence training pacing options and custom training, as well as beep options, where again you're designing a condition where you either want a beep cue, don't want a beep cue. You want the patient to pay attention to targets changing, colors, etc. So I have selected my targets, and I will click done. Targets are not available in ramp mode due to the unavailability of biofeedback. This limitation is not present in a CRS system, as biofeedback is available in all modes, and therefore so is the ability to use targets. So on to the case study. Today I will demo a case study in which we will focus on the effects of commercial space travel on balance. The original sensory organization research, which led to the invention of the Dynamic Balance Manager system, was performed on astronauts who during space travel were exposed to prolonged absence of gravity. The SOT protocol to this day is used by NASA to evaluate and rehabilitate astronauts. In this study, I am hopeful to test the first group of commercial space travelers who are due in space by the end of 2013. While the absence of gravity is likely to be brief, these travelers do not undergo the same extreme training which the astronauts must endure. Since per current commercial space design, the travelers are not likely to move around at all and are likely to place their bodies in substantial stress from multi-phase ascent and descent. Conditions like significant swelling of limbs, considerable disorientation, etc., are likely to be seen among a diverse population of space enthusiasts. I have with me Christina, who will be my pilot test subject for my study. So first, I use my clinical SOT protocol to establish a baseline for Christina, whose performance is compared to normative data. I will also retest Christina using the clinical SOT when she returns from space. This is part of the beauty of the Balance Manager system option with data software, because it provides me the capability and freedom to use both clinical and research protocols for my research. So I will go ahead and construct the clinical SOT protocol, which if you are familiar with, will consist of 6 conditions, 3 trials each, but I will increase the test time to 60 seconds. So going over all the functionality I explained earlier, I will create a new test. I will name this test 60-second SOT. For condition 1, which in a clinical SOT protocol is surround and support are fixed, so I will create surround support fixed 60 seconds. Sway. I'm sorry. Condition 1 is both are fixed. I will assign 3 trials to this condition, and I will advance to the next condition. Again, condition 2 of SOT is surround support fixed, but I will instruct my Christina to have her eyes closed during this condition. Again, 60 seconds, 3 trials. Next. Condition 3 of the SOT, the surround is in sway mode at a gain of 1, but the support is fixed, and the patient is instructed to keep their eyes open. Again, 60 seconds, 3 trials. Next condition. Condition 4 is the support is in sway mode at a gain of 1, and the surround is fixed. The patient will be instructed again to keep their eyes open. Three trials, 60 seconds. Thank you. Condition 5, where the support and where the support is a sway gain, and the surround is fixed, but the patient is instructed to have their eyes closed. Three trials, 60 seconds. And the last condition, condition 6, where the support and surround are both in sway gain at sway mode at a gain of 1, and the patient will be instructed to have their eyes open. Three trials, 60 seconds. Now, if during the study I find that the gain of 1 is not sensitive enough, I can adjust my settings to use a higher gain, like 2.0. I could even transform the study further for higher sensitivity and transform it to be like the Hedgehog SOT protocol, where for each condition I would select to collect the precision 3 degrees of freedom data, and I would instruct the patient to move their head in either the yaw, pitch, or roll plane. but I will not be doing that here. So I'm just going to go back to condition 3, in which I will, in sway, allow the visual to have a gain of 1. Condition 4, in which the support, which is the rotate, will be at gain of 1. Condition 5, in which the support will be at the gain of 1. And condition 6, in which both rotate, support, and the surround are a gain of 1. And I have here basically recreated the clinical SOT protocol, but have assigned 60-second trial duration. That is how I am wanting to expand on the existing 20-second trials of the clinical SOT. I will go ahead and navigate to clinical. And again, as you can see here, it is I personally recommend that when you name conditions, it really does help to alert you of what dynamic conditions are about to take place. So go ahead and Christina, get up on the force plate. I put Christina in the harness. Of course, you always want to harness your patient. I will go ahead and click the start button. I will ask her to stand upright with eyes open. That is the condition 1 of SOT, and I will initiate the trial. Now, just like the clinical SOT, I have turned off the patient monitor. That is important. They should not get their cues from the monitor. Okay, thank you, Christina. We won't go through all the trials. There's 18 of them. After the trial is done, the software does a prompt to ask me if I want to save the data, and I can certainly review the trace of my patient and choose to not save the data, which would simply the software would not advance further and would allow me to repeat the trial. In contrast to the CRS system does present performance feedback after every trial, where you could actually see your patient's COF, COG in both X and Y direction, as well as motor positions and whatnot. So I will say yes to save the data. I will enter a post-test comment. Your shoes. This is important. And the data would be uploaded after the trial. Now, in contrast to the CRS system, the data is streamed real time and there is no such delay. The data is present at the moment that you end the test. So it's a much faster operation of the software, higher utilization, etc. We have basically demonstrated how an clinical SOT protocol can be recreated in the research environment with the addition of modifying some fields like trial duration. Again, you could up the gain for higher sensitivity. You could engage the head tracker and ask the patient to move their head to further increase the sensitivity of the testing. One other thing I'd like to show is this randomized conditions functionality. If you are retesting, if your population if during your research the population is such that they would come back time after time, you by pressing the randomized condition checkbox, the software will randomly pick conditions and order them such that the patient would not know what condition is coming next. Also, every time the data collection starts, the dynamic system will send a sync output signal so that if any other devices need to be synchronized with the balance system, they would be able to communicate. In contrast to the CR system, there is a wealth of integration options for accepting signals from other devices, outputting to other devices, as well as initiating ramp conditions, etc. Quite the system. That will conclude this case study. I will go ahead and exit to the main menu, and I will go ahead and advance to the static to the research module, which is available for the static systems. If you have a dynamic system with a long force plate or a short force plate or VSR Sport, and you buy the data package, you will be allowed research on both your dynamic and static. So select stable conditions, click on setup. Now the research capabilities on a static system are quite simplified. There are no moving motors, there's just a static force plate. Just like the dynamic system, you can create a test or a set of tests, conditions. You can name your conditions. The trial duration is also limited to 190 seconds. You can show cursor during testing. You can show trace or not show trace. If you have the envisioning protocols or the head shake protocols option, you also are able to use the head tracker to collect additional data. You can create targets in both the degree domain and in the inch domain. The research module on a static system can be effectively compared to custom training, but with the added capability to save raw data for export and offline analysis. While the custom training allows a no time limit mode, it allows it because raw data is not provided. Since data software does provide raw data, the trial duration is limited to 190 seconds. That is just the general overview of the static. The testing screens are just the same. If you have multiple conditions, you can randomize them, and that is all that I will cover on the static. Now, the data that you have collected is accessible via an export, NeuroCom system data export. I will navigate to present the export options. Motor positions will only be exported if the dynamic system condition was collected at 1K kilohertz data rate. The load cell data are presented at all times. Center of force, center of gravity, accessory channels if you selected any, or auxiliary 3 degrees of freedom data, which is available if you enable your head tracker collection. This decimal precision from 1 to 5 decimal points, data delimiter, file types, if you want all the data to be exported into a single file, or you would like data each trial to be in its dedicated data file. So for the demonstration of the exported data, I will go ahead and select all of these. I will click Save. I'm going to go ahead and select Christina. And when I click on Export, since I have collected data on both the dynamic system and the static, they are both systems write to Christina's file. And when I export the data, I will have access to both dynamic and static. So now we already have a file for review, and here we are. So when you open the data that has been exported, as you can see, it is in a file delimited format. It is very friendly for import into Excel, into MATLAB, etc. It does provide a file header, which gives you some information about when it was collected, what the software version was, what Christina's date of birth, height, things that you can use in categorizing, the subject, male, female. There's such data. There will be such data available if that's what is of interest. How long the trial duration took, what the data rate was, what the trial settings were, which mortar you used, whether you used targets. All this information is available. The data is exported sequentially. If your data rate was 100, that means that data point 1 and data point 2 were 10 milliseconds apart. At 10th data point, you would be 100 milliseconds into your testing. The dynamic system provides 5 load cell data, both the left front, right rear, shear, left rear, and right front. In contrast to the CR system, which provides 2 independent force plates, each with 6 degrees of freedom. This is quite a lot less data, but it is still very usable data. You're given the center of force and center of gravity. If we use the head tracker data, you would have your yaw, pitch, and roll data along the side over here. Additionally, if your trial was collected at 1 kilohertz data, you would have motor position column right over here, which you can use for analysis. That, I think, covers the exporting functionality. One other last thing that I would like to cover is when you exit into the main screen, we'll go ahead and navigate to the settings. The setting of use multi-group database, directory database management allows you to separate your research population between different projects, different departments in school, in clinics, and it's very, very helpful. No one will add data to a patient in your study. A couple other things, auto-save trials. If you don't want to be prompted, would you like to save this data? Upon clicking auto-save trials, the software will auto-save trials. Show post-test comment. If you don't want to be bothered by entering post-test comment, or simply uncheck this button and that will not be presented to you. Auto-export trials. This functionality will initiate exporting of your trials right after you finish. You choose to save your trial using the export options you had previously selected. That basically covers the functionality of the research module. If you have any questions, we will gladly accept them and create a part 2 of this presentation.
Thank you so much, Daniel, for that informative presentation. This Balance eSeminar will be posted on the NATIVES education site, which is nervecenter.natives.com. And please do check back regularly for future Balance eSeminars that you can register for. Thank you so much.